Just a minute. I think there is some issue. Okay, fine, no problem. So let me show you. This is going to be the first tutorial. Fine. The first tutorial is about introduction to signals and systems, unit number 1. And the very first problem is sketch signals, step signal, ramp signal, parabolic signal, and impulse signal. I think you have studied about step signal, ramp signal, parabolic signal, and impulse signal in control system, right? Am I right? Have you studied it? I'm asking you. This is going to be your first problem, Shamik. Write down the first question. Shamik, Aman Ali, Shamik, and Vijay. It applies to all of you. Write down the first question. That is sketch signal, step signal, ramp signal, parabolic signal, and impulse signal in continuous time and discrete sequence. In continuous time and discrete sequence. Vijay, if you don't want to do anything in the class, you can leave. It's up to you. Vijay, I'm asking you. If I remove you from the class, you won't be able to attend my next session. Understand? Aman Ali and Shamik, this applies to you also. I don't want to tell you again and again. Sketch signal, step signal, ramp signal, parabolic signal, and impulse signal in continuous time and discrete sequence. Now, let me explain the basic of representation of signals. Okay. We have already studied about different types of signals and classification of signals, right? So there are 4 ways to represent a particular signal. One is the graphical representation, what we normally do, right? We always draw a signal, right? And it is the most appropriate way also, right? So graphical representation is used in continuous time signal as well as discrete time signals. CT stands for continuous time signal. And DT stands for discrete time signal. So graphical representation is the most convenient one and widely used in signals and systems, right? And it is used in both continuous time and discrete time. Another one is the functional representation. Functional representation means we represent a signal using a mathematical function. Okay? We represent a signal using a mathematical function, or you can say mathematical equation. We call it functional representation. This functional representation is used in both continuous time and discrete time. Next one is the tabular representation. Tabular representation is used in discrete time always. And the fourth one is the sequence representation, which is used in the discrete time. Okay, that means first two are applicable to continuous time signal as well as discrete time signals. Third and fourth are used in only discrete time signals. I think you are aware of the definition of continuous time signal and discrete time signal, right? Continuous time signal is the one which is defined at every instant of time. Okay, and the variable, independent variable, is small t. Whereas discrete time signal is defined only at specific interval and independent variable is n. Right? Independent variable is n. Understood? So let us start with the graphical representation. This is a graphical representation. Yes? I hope you are writing also. This is called graphical representation. Okay. In graphical representation, what we do, let's say there is n on x-axis and x of n on y-axis. Fine. Now, let us consider the signal with values like this. This is the 0th instant. This is n is equal to 1. Then we have n is equal to 2 and n is equal to 3. So we call them instants 0, 1, 2, and 3. This is -1, this is -2. And at this instance, the values are x of -2. That means if n is equal to -2, then x of n is equal to -3. Okay, so this value is -3. At x of -1, that is a -1 instant, the value is 2. At 0th instant, the value is 0. At first instant, the value is 3. At second instant, the value is 1. And at third instant, the value is 2. So this is some signal which is represented graphically. Okay. By the way, this is a discrete time signal. Okay. On x-axis, you have n. The second representation is the functional representation. So in functional representation, as you can see, we have written a kind of mathematical equation. Now, because this function is not defined exactly because the value is constantly changing. So we are writing it like this. X of n is equal to -3 for n is equal to -2, 2 for n is equal to -1, 0 for n is equal to 0, 3 for n is equal to 1, 1 for n is equal to 2, and 2 for n is equal to 3. Another way is x of n is equal to 2 raised to n for n greater than or equal to 0, and it is 0 for n less than 0. Now this is a mathematical function. Fine. This x of n is equal to 2 raised to n for n greater than or equal to 0 and 0 for n less than 0. This is a mathematical equation. Now, the first one is already drawn in the previous slide. Fine. How do you draw the second one? How do you draw the second one? So we can draw it like this. Now I will draw, first of all, I will draw x-axis. We call it n. And the equation is that x of n is equal to 2 raised to n for n greater than or equal to 0, and it is 0 for n less than 0. Fine. Which means that if n is equal to 0, then x of n is equal to 2 raised to 0. What is 2 raised to 0? Aman Ali, what is 2 raised to 0?
N is 0.
What is 2 raised to 0?
N is 0.
I am asking you, what is the value 2 raised to 0?
0.
It's not 0, it is 1. Okay? If any number x has power 0, then the answer is 1. Understood? Okay. Then if n is equal to 1, then x of n is equal to 2 raised to 1, which is equal to 2 raised to 1 is equal to Shamik. What is 2 raised to 1?
2.
2, sir. It is 2. Similarly, if n is equal to 2, x of n is equal to 2 raised to 2, which is 4. If n is equal to 3, x of n is equal to 2 raised to 3 is equal to 8, and so on. See, it says that n greater than or equal to 0, which means that n will start from 0 and it will go up to infinity. There is no end to it. Fine. Now let's write 0, 1, 2, 3, and 4. Okay. Now, just for your understanding, I am just separating them. So 1, 2, 3. Similarly, here I will have 1, minus 1, minus 2, minus. Next, write the value 2 raised to 0 is equal to 1. So it's 1 here. 2 raised to 1 is equal to 2. So I will draw 2 here. So this is 1. This is 2. 2 raised to 2 is equal to 4. So it's going to be 4. And 2 raised to 3 is equal to 8. So I will draw 8 here. And then it continues. So to show that it continues up to infinity, I will show 3 dots, 1, 2, 3. Fine. For n less than 0, for n greater than 0, it is 2 raised to n. For n less than 0, I know that it should be 0. So I will put 0 everywhere. Minus 1, minus 2, minus 3. Understood? And then you can show that how the graph is changing. It's a sort of exponential signal. We will study about that. It is called exponential signal in discrete time. Okay? But remember, for infinite signal, after few instances, you put dot, 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 which means that this signal continues up to infinity. Okay? Let's get back to the original discussion. This is a tabular representation. This is called tabular representation. You must have studied this kind of representation when you were in school during 8th standard or 9th standard. Okay? Where we had preliminary knowledge of graph. At that time, we used to write x values. So this n is x value, and x of n means it's y value. So for different x values, we have different y values. It's the same signal which we have drawn earlier. Understand? The same signal which we have drawn in the first slide. Okay. So it is for x is equal to -2, the value is -3. For x is equal to -1, the value is -2. For x is equal to 0, the value is 0. For x is equal to 1, the value is 3, and then it continues. Fourth one is the sequence representation. Shamik, pay attention here. This is called sequence representation. Why this is important? Because in examination, the examiner will give you the sequence in this form. Fine? The examiner will assign the sequence in this form, where he will put the sequence like this: -3, 2, 0, 3, 1, 2. Now from this, you are supposed to interpret that how I can draw this. It is very simple. The arrow, this denote 0th instant. So these are basically n. Arrow denotes 0. Everything on the right hand side, they are positive instants. For example, this is 1. This is n is equal to 2, and this is n is equal to 3. Everything on the left hand side of the arrow denote negative, that is -1, -2. So these are basically instants. These instances are not given, remember. You need to define these instances from the arrow. So arrow is your 0th instant. And samples on the right hand side, they belong to positive integers. Samples on the left hand side, they belong to negative integers. And you cannot skip any sample of n here. Okay, so after 0, you can't say that it's sample 2 and 4 and 6. No, it's not possible. This will always be sample number 1, this will always be sample number 2, and this will always be sample number 3, and then it may continue. It depends. Okay. Okay. So this is how you represent the signal. Now we are going to study about these 4 signals or functions. Why these elementary signals are introduced again? Because these elementary signals, they serve as a basis in signals and systems. So you will need them a lot. Step function, ramp function, parabolic function, and impulse function. Though you have studied it in the control system, but we will revisit it because we have to study them in CT, that is continuous time, as well as DT, that is in discrete time. Okay. Now, starting with the first problem of tutorial 1, the continuous time step function, this cross means you don't have to write this at this moment. Only focus on this one, and this one. અને આ ડ્રો કરવાનું છે તમારે, રાઈટ બી કરવાનું છે, ડ્રો પણ કરવાનું છે. As I say, at the end of session, હું તમારી પાસે આની સ્કેન કોપી માંગીશ Google ફોર્મમાં. Okay, the continuous time step function is defined as u of t is equal to 1 for t greater than or equal to 0 and 0 for t less than 0. We call it unit step function. We call it unit step function because it has an amplitude of 1. Simple. It has an amplitude of 1. It starts at 0. As I said, for t greater than or equal to 0, it is 1. So it starts at 0. And then it continues. Before 0, the value of unit step function is 0. Now, why is this important? Because this denotes the application of a DC supply to any system. Understand? તમે કોઈ પણ સિસ્ટમ ને ડીસી સપ્લાય આપશો તો એ કઈ રીતે બિહેવ કરશે એ સમજવા માટે તમારે યુનિટ સ્ટેપ ફંક્શન સમજવું જરૂરી છે. See, let's say you have thrown the switch at t is equal to 0. And I think you are well aware of initial condition, right? You are aware of initial conditions. Fine. So at initial condition, we start giving the supply to the circuit. At that moment, your DC supply will change from 0 to some value VDC. Now, for analysis purpose, we assume that we are giving only 1 volt. Fine. That will make your calculations simpler. Okay. Fine. So this is u of t. It's called unit step function. In discrete time, don't write this, don't write this. You are supposed to draw this and this. In discrete time, the unit step function is defined like this. Vijay and Aman Ali. You are still attending without video. Discrete time step function is defined like this. Okay, it has the same shape, but the representation is different. It is only defined at 0, 1, 2, and 3, and so on. So it is defined at discrete interval of time only. Fine. At n is equal to 0, it starts and it becomes 1. Then at n is equal to 1, again it is 1. At n is equal to 2, it is 1. N is equal to 3, it is 1. And then it continues up to infinity. So up to infinity, you will get 1 magnitude. Before that, you have 0, 0, 0. So all values are 0, 0 before n is equal to 0. Now this is very important. See, when we say n greater than or equal to 0, it means that the signal should start at 0. Fine. Whereas this is the shifted version. We will talk about shifted version later on, not now. Now the unit ramp function. So the continuous time unit ramp function R of t, it increases linearly with time, and it is defined as R of t is equal to t for t greater than or equal to 0. So the equation is t for time t greater than or equal to 0. Okay. Before that, the value is 0. That means the signal doesn't exist before 0. And after 0, it increases. Is it clear? Now, if you see, this equation is as good as y is equal to mx plus c, where y is equal to r of t, and this is t. Now, if you compare these two equations, you can say that y is equal to r of t, x is equal to t, c is equal to 0, because t plus kasud nathi jo tam. There is nothing after t. So c is equal to 0 and m is equal to 1. And that's why it is written here that slope is equal to 1. So in unit ramp function, the slope is always equal to 1. Understand? Are you aware of this equation? Are you aware of this equation y is equal to mx plus c? You can unmute yourself, right?
Yes, sir.
Okay. This is a very popular form of line, right? Line equation. And this ramp is nothing but a line. Okay. See, અને જેટલું carefully સમજશો, જેટલું ધ્યાનથી સમજશો, એટલું તમને હેલ્પફુલ રહેશે. ઓકે, આ ખાલી હું તમને ઇન્ટ્રોડક્શન આપું છું. જે ખરું જે નોલેજ છે ને, અથવા ખરી એપ્લિકેશન છે ને, એ તમારા 6th એક્ઝામ્પલ પછી સ્ટાર્ટ થશે. Right now, we are only playing with fundamentals. Okay, so this is called unit ramp function. And then, most important thing, it can be obtained by integrating the unit step function. So unit ramp function is basically obtained by integrating unit step function. So R of t is obtained by integrating U of t with respect to time, of course. Signals and systems ma integration માટે variable એક જ હશે and that is t. જો integration કરશો તો variable એક જ હશે and that will be t. Right? And a u of t, we know that u of t is equal to 1. We know that u of t is equal to 1 for t greater than or equal to 0, and it is 0 for t less than 0. So let us consider the condition, this one. કારણ કે 0 માં તો એમ પણ કશું નહીં થાય. So then you have integration 1 into dt. What will be the answer? Integration 1 dt. So answer આવશે? Integration 1 dt. One તો constant છે, એને consider કરવાની જરૂર પણ નથી. Integration dt. What will be the answer? Integration dt. It will be t. Simple. And for t greater than or equal to 0. And that's why you get R of t is equal to t. So you can say that R of t or the unit ramp function is obtained by integrating the unit step function. આ ખાસ યાદ રાખજો. ઓકે, થઈ ગયું હોય તો આપણે નેક્સ્ટ લાઈન પર જઈએ. નેક્સ્ટ સ્લાઇડ. આને અત્યારે ડિસ્કસ નહીં કરીએ. We will discuss it later on. This is the discrete time representation of unit ramp function. So the discrete time unit ramp sequence, now the word will change. Instead of signal, we use the word sequence. So if you ever come across the word sequence, do not get confused. It refers to the signal in the entire course. Okay, in this entire course of signals and systems, right, we use the word sequence for discrete time signal. Now here, if you see, for instant number 1, 2, 3, 4 and 5, the values are 1 here, 2 here, 3 here, 4 here. And that's why the equation is n. If n is equal to 1, R of n is equal to 1. If n is equal to 2, R of n is equal to 2. If n is equal to 3, R of n is equal to 3. So R of n is equal to n for n greater than or equal to 0. Before that, anyway, it is 0. Okay, I hope you have completed this. Now we will move to unit parabolic function. So the parabolic function p of t is defined as p of t is equal to t square by 2 for t greater than or equal to 0, and it is 0 for t less than 0. Shamik, તમે ટીવી પછી જોઈ શકો છો. Whatever you are watching, you can watch it later. Okay? Please be attentive, stay focused. Okay, so parabolic function is given by t square by 2, t greater than or equal to 0. And in terms of graph, it will look like this. Now this equation is the equation of parabola. Have you studied about parabola? Aman Ali, Vijay, Shamik?
Yes, sir.
Parabola વિશે ભણ્યા છો?
No, sir.
નથી ભણ્યા? વિજય?
No,
અમન અલી?
sir.
ગુજરાતીમાં ભણ્યા છો?
યસ સર બીઈડી માં સ્ટડી કર્યું છે. બી સબ્જેક્ટ આવતો ને એમાં.
ઓકે. I think એને ગુજરાતીમાં શું કહેવાય છે મને એક્ઝેક્ટલી ખ્યાલ નથી, but we call it પરવલય. પરવલય ભણ્યા છો?
Yes, sir. Yes, sir.
So this is the same equation as y is equal to ax square. Understand? Instead of x, I am putting t everywhere. Okay, so you can say that it is y is equal to t square by 2. And I will show you. If you extend this, sorry, if you extend this here, now it will look like a parabola. Okay, તમે જે પેરાબોલા ભણ્યા હશો ને એ કેવો હશે? બરાબર?
Yes, sir.
Time we study a parabola which looks like this. Okay,
Yes, sir. Yes.
but this is different. Here we are taking ax square. What you studied, it was y square is equal to ax. That's what you studied. Okay, so there is a fundamental difference here. Y square is equal to 4 ax is it will look like this, whereas y is equal to ax square will look like this. So it's a mirror reflection with respect to y axis, and here the mirror reflection is with respect to x axis. Fine. Okay. Okay. Now, unit parabolic function is one of the basic elementary signal, right? And it is obtained by integrating the ramp function. હવે તમને એવું લાગશે કે t square કેમ use ના કર્યું? Y is equal to t square કેમ ના આવ્યું? T square by 2 કેમ આવ્યું? Right? So the reason is that parabola p of t is obtained by integrating r of t. That is unit ramp function. Now unit ramp function is defined as t for t greater than or equal to 0. Okay, r of t is equal to t for t greater than or equal to 0, what we studied in the last slide. So this is going to be integration of t dt. So you will get t square by 2, which is the integration of t dt. And that's why we write p of t parabola as t square by 2. Similarly, discrete time, don't write this. Discrete time unit parabolic sequence is defined as p of n is equal to n square by 2, where n is greater than or equal to 0 and 0 for n less than 0. However, now we have already studied about the classification of signals. Now tell me, this signal, is it a causal signal or non-causal signal? Tell me. In the last lecture, we studied about causal signal, definition of causal signal and anti-causal signal and non-causal signals. So you tell me, is this signal causal signal or non-causal signal? I will show you this. Now looking at the signal, you should be able to judge whether it is a causal signal or non-causal signal. What is the definition of causal signal? The signal which exists only for positive time instants is causal signal. Understand? The signal which exists only for positive time instants is called causal signal. And the signal which exists only for negative time instants is called anti-causal signal. Okay. And the signal which exists for positive as well as negative, that is called non-causal. Now you look at the graph and tell me whether it is a causal signal, anti-causal signal, or non-causal signal. Look at the signal. It exists only for t greater than 0. And that is clearly mentioned in the mathematical function also. Signal exists only for t greater than or equal to 0. This signal is called causal signal. આપણે અત્યારે સ્ટડી નથી કરવાનો, પણ હું જસ્ટ તમને પૂછું એટલે છું કારણ કે તમે રિકોલ કરી શકો, રાઈટ? તમારે રિલેટ કરવાનું છે કે જે કંઈ બી આપણે સ્ટડી કરીએ છીએ એને રિલેટ કરવાનું છે તમારે, રાઈટ? Okay, so this is also causal signal. Now you look at the graph here. For now it is n square by 2, which means for n greater than or equal to 0, which means if n is equal to 0, P of n is equal to 0 square by 2, so 0. When n is equal to 1, P of n is equal to 1 square by 2, so you get 1 by 2. When n is equal to 2, P of n is equal to 2 square by 2, so you will get 2. Where n is equal to 3, P of n is equal to 3 square by 2, so it is 9 by 2. Understood?
Yes, sir.
So here the value is 0. Here the value is 1 by 2. Here the value is 2. Then you have 9 by 2. And then you have 16. By 2. And that is 8. And if you join them, this looks like a parabola. Okay, where the negative part is missing. Remember, it is not defined for negative time instants. So this is missing. It is 0 there. Shamik, Vijay, Aman Ali, આ બધું draw કરવાનું છે તમારે. And what we are discussing is only question number 1 of tutorial number 1. So do it quickly so that we can discuss other problems also. Okay. જે ગુજરાતી સમજતા હોઈએ તો આ શું છે? પાશેરામાં પોણી જેવું છે હજી. હજી આગળના જે એક્ઝામ્પલ છે એ તો ભયાનક છે. Okay. So I hope you have completed. Vijay, Aman Ali.
Yes, sir.
Now the next one is unit impulse function. ડિપ્લોમામાં high voltage engineering study કર્યું છે? Have you studied high voltage engineering? No? Are you aware of this term impulse? Are you aware of this term impulse? Impulse testing is done on insulators, especially transformers and power apparatus. Okay. So impulse is a very important signal. Okay. It's the most widely used elementary signal, in fact. And as the time progresses, you will realize that this is very, very important signal. And the beauty of this signal is that if you try to find out the Fourier transform of unit impulse function, it is 1. You have studied about Laplace transform of unit impulse function, and that is equal to 1. And if you try to find out the Z transform of unit impulse function, then also it is 1. So in fact, in unit number 3, what Dr. Ved is discussing right now. So when you go ahead, you will come across this function again and again, and you will find that if you apply any of this transform to unit impulse function, you will always get one answer, and that is 1. And that's why, if you recall, you came across one term very frequently in control system. Control system બધા ભણી ગયા થર્ડ સેમિસ્ટરમાં? ઓકે, હવે તમારામાંથી કંટ્રોલ સિસ્ટમ ક્લિયર કરી લીધું એવા કેટલા છે? ઓકે, ફાઇન. Priyanka, have you cleared control system? Aman Ali?
Yes, sir.
Control system clear છે આપણું? ઓકે, ના થયું હોય તો ગભરાવાની જરૂર નથી. હું ખાલી એમ જ પૂછું છું તમને. એટલે પૂછું છું કારણ કે if you have cleared control system, then you must have come across this term impulse response. Okay, so many times it is given that impulse response of a given system is this, right? અને એનું રીઝન છે, જો ઇમ્પલ્સ રિસ્પોન્સ આપણે કેમ ઇમ્પલ્સ લાપ્લાસ ટ્રાન્સફોર્મ ઇમ્પલ્સ નો તમે કેલ્ક્યુલેટ કરો તો શું આવે? 1. હવે now you just tell me that y of s upon x of s, where x of s is the Laplace of input, y of s is the Laplace of output. What is y of s upon x of s? G of s. What is G of s? You call it transfer function, right? You call it transfer function, right? હવે આપણે સિગ્નલ્સ એન્ડ સિસ્ટમ્સમાં પણ ભણવાનું છે, એટલે હું તમને અત્યારે કહું છું. It is called transfer function. Now, x of s is the Laplace of x of t. If x of t is equal to delta of t, that means impulse function, then Laplace of x of t is Laplace of delta of t, and the Laplace of delta of t is always 1. So એનો મતલબ શું થશે કે y of s upon 1 is equal to g of s. આવું થાય? તો એનો મતલબ શું થાય કે y of s અને g of s બંને સેમ થઈ જાય જો x of s impulse હોય, function હોય તો. Understand?
Yes, sir.
આઉટપુટ જે છે એ સેમ એઝ ટ્રાન્સફર ફંક્શન થઈ જાય, અને એટલે આ ટર્મ જે છે વારંવાર આવે છે ઇમ્પલ્સ રિસ્પોન્સ. ફાઇન. Okay, let's get back. Fine. Now the definition of unit impulse function is like this. We say that integration minus infinity to infinity delta of t dt is equal to 1. હવે તમે આ રીતે જોશો ને તો it will be very difficult for you અને કોઈ પણ આપણે engineering study કરતા હોઈએ કોઈ પણ વ્યક્તિ માટે આ સમજવું થોડું difficult છે unless you are a mathematician or unless you have a very good command over mathematics. What kind of equation is this? Integration minus infinity to infinity delta of t is dt is equal to 1 and delta of t is 0 for t not equal to 0. मतलब કે t ની વેલ્યુ 0 ના હોય તો આઉટપુટ શું હોવું જોઈએ 0. પણ તમે જો ઇન્ટિગ્રેશન કન્સિડર કરો અને આનો મતલબ આવો થાય. આનો મતલબ કેવો થાય? For example, we have a function like this and this is t. So you may start from minus infinity somewhere and you may go up to infinity in positive. Okay? But in between, you have a signal of very, very small width. So at t is equal to 0, you can say the signal is defined. But for all other values of t, the value is 0. It is defined at only t is equal to 0. Now, if you see the width of this signal, then I call it delta. So the width of this signal is delta. And you assume that limit of delta tends to 0. So that obviously the signal will be 0 for all other values, but the height or the amplitude of this signal is 1 upon delta. The height of this signal is 1 upon delta. Try to understand, it's very, very weird. Okay. Especially for those who are very novice, right? So width is delta and delta tends to 0 and height is 1 upon delta. Okay. If you do this, what will be the area? There is a small rectangular strip, you can say, having height delta and width, height 1 upon delta and width delta. What will be the area of this strip? Rectangular no area કેવી રીતે calculate કરો તમે? Tell me. How do you calculate the area of rectangular? All of you. How do you calculate the area of a rectangular? Rectangle, you can say. How do you calculate the area of a rectangular function? અરે ભાઈ આટલું તો ખબર હોવી જોઈએ ને, તમે આવું કેમ કરો છો? If this is the rectangle, let's say this is height and this is width, then area is equal to width into height. Right? Or whatever you define, okay? If you define width as a L and height as H, then it is HL. Okay. Now, what is the height here? It is 1 upon delta. And what is the width here? It is delta. So what will be the area? 1. So even if limit of delta tends to 0, even if it is very small, it has very small width, but still the area is 1. હવે area જે છે mathematically calculate કરવો હોય, so how do you calculate it? You always apply integration from minus infinity to infinity, right? X of t dt. And this way, you can calculate the area under the curve. આવું તો ભણ્યા છીએ ને આપણે મેથેમેટિક્સમાં. When you do the integration, it is basically what? Area under the curve. Understand? Understand or not? ખ્યાલ છે કે નથી ખ્યાલ તમને? મેથેમેટિક્સમાં ઇન્ટિગ્રેશન કેમ યુઝ થાય? જ્યારે તમે ઇન્ટિગ્રેશન કરો ને તો શું મળે તમને? એરિયા. અને જો તમે ડબલ ઇન્ટિગ્રેશન કરશો તો તમને શું મળશે? વોલ્યુમ. ઓકે, હવે વોલ્યુમ વિશે તો આપણે કઈ બહુ ચર્ચા અત્યારે કરવી નથી. ફાઇન. બટ એરિયા જે છે that is very important. Remember. Fine. So we can erase this. So here x of t is nothing but delta of t. So minus infinity to infinity delta of t dt, area under the curve, this gives you 1. So the basic definition of unit impulse function says that integration minus infinity to infinity delta of t dt will give you 1. But at the same time, value of delta t, this is delta of t, for any value other than t is equal to 0 is 0. So here, everywhere it is 0. Okay?
Yes, sir.
Fine. This is for unit impulse function. So if somebody asks you to draw the unit impulse function, આપણે જે ડિફાઇન કર્યું હતું એ શેના માટે હતું? મેથેમેટિકલ ફંક્શન હતું. If somebody asks you to draw the unit impulse function and define the unit impulse function, then you should say that delta of t is equal to 1 for t is equal to 0 and 0 for t not equal to 0. And you should draw it in this manner. Understand? Shamik.
Yes, sir.
Okay. So I hope you have drawn this. Priyanka, Tiger. Okay. Do it.
થઈ ગયું sir.
Okay, fine. Similarly, the discrete time unit impulse function is defined like this, where delta of n is equal to 1 for n is equal to 0, and it is 0 for n not equal to 0. Understand?
Yes, sir.
Okay. Now, if you look at this, if you look at this function and this function, this is in continuous time and this one is in discrete time. Both look same. Understand? Both look same. Okay. And that's why the discrete, this unit impulse function has a big role when you want to relate the continuous time and the discrete time. Okay. So I hope you are done with this.
Yes, sir.
Okay. Now, the second problem of the same tutorial is x of n is equal to 2 raised to n for n greater than or equal to 0 and 0 for n less than 0. I think we have already defined this in the very first problem. So this is nothing but just a minute, sorry. Okay. Okay. So this is the first problem of problem number 2. This is called discrete time exponential signal. So in second one, you are asked to draw this function. Now the next. In the next, you are asked to draw this function. I think we have already seen this, right? So basically, when you have this type of function, first thing that you can do is convert it into the table. This is n, and this is x of n. Okay, this is -2, -1, 0, 1, 2, 3. This is just a minute. Okay. I was disconnected actually. My PC was disconnected. This is the arrow. And you have to draw the signal. So this is 0, 1, 2, 3. -1, -2. So at 0, you have 0 value. At 1, you have 3. At 2, the value is 1. At instant 3, the value is 2. At instant -1, the value is 2. And at instant -2, the value is -3. So this is simply an exercise of how you can draw a discrete time signal. Okay. Time for the third. The third one is this. U of t minus a is equal to 1 for t greater than or equal to a. So they are basically shifted unit step function and shifted unit ramp function. Now let me explain this shifted and what does it mean? What do you mean by shifting? And that's why I had skipped it earlier when I was talking about unit step function. I had skipped this shifted step function. Now this is unit step function. Okay. And if you look at this, it is defined at A. It is defined at A. See, what does it say? U of t minus A is equal to 1 for t greater than or equal to A. and A is a positive number. Whereas it is 0 for t less than A. So we defined one number A here. Okay. For values of t greater than or equal to A, you get 1. And for values of t less than A, you get 0. This is called shifted unit step function. Okay. This simply means that we have provided a delay of time A. For example, let us say that our session is supposed to start at 2. So this is 2. Instead, I start at 2:30 p.m. What will you say? આપણું સેશન 2 વાગે સ્ટાર્ટ થવાનું હોય એની જગ્યાએ 2:30 એ સ્ટાર્ટ થાય. What will you say? The session is delayed by 30 minutes. Understand? Okay. So in this case, we have provided a time delay in the signal. The signal was supposed to start at 0. Instead, it is starting after time A. Okay, so it is delayed by A seconds. This operation is called time delay. Okay. So if somebody asks you that draw u of t minus 2, let's say, draw u of t minus 2. Okay, so u of t minus 2 means that it is equal to 1 for t greater than or equal to 2, and it is 0 for t less than 2. So here okay, so here what will happen? This is 2, let us say this is 0, this is 2. So the signal starts at instant 2. It has an amplitude of 1. It starts at 2. After 2, the magnitude is 1. And before 2, the amplitude is 0. This is called u of t minus 2. We call it time delay. Now let us understand it like this. If the session is scheduled at 2 p.m., instead it starts at 1:30 p.m. What will you say? What? There are two words. One is prepon and other is advanced. Okay. So if the session was scheduled at 2 and it starts at here somewhere, sorry, it starts at -2. Fine. So on time frame, let us understand it like this. On time frame, this is 2 p.m. If you go forward, this is 2:30 p.m. and you say that it is delayed. And if you go ahead, this is 1:30 p.m. and then you call it advanced. By the way, there is nothing like negative time. એવું છે કોઈ દિવસ એવું સ્ટડી કર્યો છે તમે કે ટાઈમ નેગેટિવ માં હોય?
Yes,
No.
sir.
હા, કર્યો છે એવું સ્ટડી?
No, sir, no.
હા.
Time negative.
ટાઈમ ક્યારે પણ નેગેટિવ માં ના હોય. Right? So this negative means it is advanced. હવે see, આપણું એક મિસકન્સેપ્શન આપણા માઇન્ડ નું છે કે આપણે નેગેટિવ હોય ને એટલે આપણે શું માનીએ કે લેટ થઈ ગયું, ડિલે થઈ ગયું, અને પોઝિટિવ હોય ને એટલે આપણે એવું માની લઈએ મનમાં કે એડવાન્સ થઈ ગયું. But this is exactly the opposite. Okay, if you are going in right hand side, that means the signal is delayed, and if you are going on the left hand side, that means the signal is advanced. Understood? Okay, so here this is called advanced. Okay, and it is defined as u of t plus 2, and u of t plus 2 is equal to 1 for t greater than or equal to શું થશે અમનલી? u of t plus 2 is equal to 1 for t greater than or equal to Amanali, Vijay and Amanali.
Yes, sir.
U of t plus 2 is equal to 1 for t greater than or equal to which value? તમે તમારો વિડિયો કેમ ઓન નથી રાખતા ડિયર? કેટલી વાર કહેવાનું તમને? This is the first time. Next time I will not allow you to remain in this session. Yes, Priyanka, you are correct. સમજાય છે? અમનલી, વિજય. Unless you are facing some very genuine issue, okay, then you can talk to the HOD and I can allow you. Okay, જો તમારે ખરેખર genuine issue હોય તો. Otherwise, I want to ensure that when you are in my session, you are studying. અને બીજું તમને કહી દઉં કે the purpose of making you write during the session is that you don't have to repeat. આજે solution થશે, you will note it down. Next time also we will do some solution, you will note it down, at the end of tutorial 1, I will try to cover most of the problems, as many problems as possible. Okay. And then you will write it in your tutorial book, a fair book. And જેવું tutorial 1 complete થશે, you will submit the scanned copy to Canvas. Okay. તો આ કરવાનો પર્પસ જે છે મજૂરી કરવાનો નથી. To ensure that you are doing everything from time to time. Then only I can help you in clearing the examination. ये समझी जजो तुम्हें.
Yes, sir.
Okay. बाकी હું તમને એક ચેનલ હેન્ડઓવર કરીશ. એ ચેનલમાં એક કન્સેપ્ટ કવર કરેલા છે તમારા આખા કોર્સના સિગ્નલ્સ એન્ડ સિસ્ટમ્સના. આ છેલ્લા લાસ્ટ 2 years થી હું એ ચેનલ જે છે એ છોકરાઓને ફોરવર્ડ કરું છું. Still students are not able to clear exam. Only you can clear the examination. હું ગમે તેટલા એફર્ટ મૂકીશ, તમારા કોઈ કામના નથી. Okay. So u of t plus 2 is equal to 1 for t greater than or equal to minus 2. Jo, it is mentioned here. And it is 0 for t less than minus 2. And that's how you define it. Clear? Similarly, the next problem is r of t minus a delayed one. If I show you the delayed one, it looks like this. Look at this. This is r of t minus a, which is equal to t minus a. So the equation of this line is t minus a. Okay. Now the question is, if it was r of t, if it was r of t, then this is r of t, which is equal to t. And this is r of t minus a, which is given by t minus a. Why is it so? Can you tell me? Unit ramp function has an equation t, whereas shifted unit ramp function has an equation t minus a. Why is it so? Think about it. I'm giving you 2 minutes to think about it, and then I will explain it.
Sir, t less than and greater than.
Sorry, તમારો અવાજ વોઇસ કટ થયો હતો. ફરી બોલો.
Sir, t less than and greater than છે એટલે.
But how did you get t minus a? Why it is not t only? My question is this. If it was t for unit ramp function, why it is t minus a for shifted unit ramp function? Okay, let me explain to you. See, it is like this. Suppose this is r of t minus a on y-axis. This is t on x-axis. Now, this is one point and this is another point. Fine. I call this point A and 0. Why A0? Because x value of this point is A and y value for this point is 0. समझाइए? I'm talking about this particular point. I think in mathematics, school mathematics, we have studied about how to define a point, right? So this point A, x-axis value is A, y-axis value is 0. તમે એનો y-axis પર પ્રોજેક્શન કાઢો શું મળશે 0 અને x-axis પર પ્રોજેક્શન કાઢો શું મળશે A. So A 0. I call it point x1 y1. And let's say this is another point. Now x-axis projection of this point is t and y-axis projection of this point is y. So I will call it t y. Why? Because it is not defined. Okay. And let's say that it is x2 y2. Now we are aware of one function in mathematics for the line, and that is y2 minus y1 upon x2 minus x1 is equal to m. આ સ્ટડી કર્યો છે કે? Yes or no? No. ઓકે, ના કર્યો હોય તો ખાસ યાદ રાખી લેજો કારણ કે લાઈન ઇક્વેશન છે ને એ બધા કર્વમાં સૌથી સિમ્પલ ઇક્વેશન છે. It is the simplest equation out of all equations that you have studied so far. Okay, and the equation of line is given by y2 minus y1 upon x2 minus x1 is equal to m. In fact, you can find out the slope of the line using this equation. Understand? If you are asked to find out the slope of the line, then you can find out using this equation. M is equal to y2 minus y1 upon x2 minus x1. But to find out the slope, you should be aware of both the points in the line. હવે આ કેસમાં એક પોઈન્ટ વિશે આપણને ખબર છે, સેકન્ડ પોઈન્ટ વિશે આપણને ખબર નથી, બટ યસ સ્લોપ ખબર છે આપણને. સ્લોપ જે છે ઇટ ઇઝ 1. ધ્યાનથી જુઓ, ઓરિજિનલ ઇક્વેશન જે હતું યુનિટ રેમ્પ, ઓરિજિનલ ગ્રાફ જે હતો યુનિટ રેમ્પનો, that was r of t is equal to t. So any comparison માં સ્લોપ ચેન્જ નથી થયો લાઈનનો, ખાલી લાઈન શિફ્ટ થઈ છે. ઓકે, that's why equation is changing. Okay, now y2 minus y1 upon x2 minus x1 is equal to m. y2 શું છે y, y1 શું છે 0. આર્ય divided by x2 શું છે t, what is x1 minus a, and what is slope 1. So y equal to y upon t minus a is equal to 1. So y is equal to t minus a. That's why you are getting t minus a. Understood?
Yes, sir.
Okay. This is called shifting operation, time shift operation of signal. સિગ્નલ પર જેટલા ઓપરેશન્સ થાય છે એમાંથી આ એક સૌથી ઇમ્પોર્ટન્ટ ઓપરેશન છે. ઓકે, that is called time shifting operation. Fine. So this is all about today's discussion. We have just started with elementary signals. Fine. In the next tutorial, we will continue with problem number 3 of tutorial 1. I have already shared tutorial 1 in our WhatsApp group. You can go through it in advanced so that we can discuss it further. Okay? આ જેટલા પણ solution આપણે કરીએ છીએ, most of them are available in Anand Kumar, Signals and Systems by Anand Kumar. Okay? તો તમે એડવાન્સમાં સ્ટડી કરી શકો છો, જેથી ટ્યુટોરિયલમાં જ્યારે પણ આવો તમે ત્યારે આપણે ક્વિકલી એને ડિસ્કસ કરી શકીએ અને તમારા જે પ્રોબ્લેમ્સ છે અથવા ક્વેરીઝ છે એને સોલ્વ કરી શકીએ. ફાઇન? ઓકે.
Okay, sir.